Please feel free to subscribe to this sideshow and append any comments and questions, which I shall endeavour to deal with to the best of my theatrical propensities. Right, I'm going to show you how to integrate 1 over sine theta, 1 over cos theta by alternative methods. I've already used one method to do this one without using a substitution, but today I'm going to use substitutions. And the first substitution I'm going to use is for this, and it's quite easy. Just put u equal to sine theta, which means du is cos theta d theta. That means d theta equals du over cos theta. All right, so I substitute in here. D theta is du over cos theta. Well, we've already got a cos theta here, so that becomes cos squared theta, which, as you should know, is 1 minus sine squared theta, and so that is 1 minus u squared, and that breaks down easily into partial fractions. Is 1/2 integral of 1 plus u plus integral of 1 over 1 minus u du. Okay. Rewrite that slightly. 1 over 1 plus u and minus 1 over 1 minus u. So to make the integration a bit easier. So here the top is the derivative of the bottom. So that is 1/2 log of 1 plus sine theta, while the other one is minus log, this is log to base e, of course, that in there, and the top here is now the differential of the bottom, so that is 1 minus u, which is 1 minus sine theta. And you can get that all as 1 log, so that is 1/2 log to base e 1 plus sine theta divided by 1 minus sine theta, and that's it. Right, I've already done one of those in a previous video without using any substitutions, but I'm going to use or redo this using a substitution, and it's going to be a substitution that is widely used whenever trig functions are involved, and that is the main reason I'm going to do this one again. Okay, and the substitution I'm going to use is let t equal tan 1/2 theta. Differentiating, we get 1/2 tan squared theta upon 2 d theta, which is 1/2 1 plus d squared d theta, because tan 1/2 theta is t. And therefore d theta is 2 dt over 1 plus d squared. We also want to see what sine theta is going to be in terms of t, so I've drawn a little triangle here. T over 1 is tan theta over 2. Using Pythagoras' theorem, that will be 1 plus d squared. And I'm just using a little bit of trigonometry here. Sine theta is 2 sine theta upon 2, cos theta upon 2. From the triangle, here's the 2. Sine theta upon 2 is t over 1 plus d square root 1 plus t squared. And cos theta is 1 over that. You multiply the two square roots together, you'll get that. And so you're down to this, which I'll write here as 2t over 1 plus t squared. We now substitute all that back into the integral here. So, first of all, what is d theta? d theta is 2t, rather 2 dt over 1 plus t squared. And what is sine theta? Sine theta is 2t over 1 plus t squared. And hallelujah, these two cancel out very nicely. And so do the 2's. That just leaves us with dt over t, which is log n of t, which is log n, and t is tan theta upon 2. And that completes it. This expression here should be in brackets. Okay, so that there's no confusion then. All right, I think that should be okay. Yeah. Please feel free to subscribe to this sideshow and append any comments and questions, which I shall endeavour to deal with to the best of my theatrical propensities.